Section 17.5 deals with the use of color indicators in acid-base titrations. We've looked at titration curves so far, sort of with the assumption that we're able to measure the pH at every point along this process. But in reality, it's often difficult to get a pH probe, and then you need to analyze the data in Excel afterward. And there's a really good way to simplify and speed up titrations without measuring the pH at all, and that's through the use of color indicators. So color indicators will be one color at the beginning of the titration, and then around the equivalence point they'll suddenly change to a different color. And that can be a signal for how you've reached the endpoint. And they seem almost magical when you first hear them described. But the way that color indicators work is actually quite simple. Color indicators are themselves weak acid, weak base conjugate pairs. So you would have HA in equilibrium with A minus plus H3O plus. Okay, and what makes a color indicator effective is that they have different colors. Let's say maybe the A minus form is a vibrant pink color, and the HA form is colorless. This is how the color indicator phenolphthalein works. Phenol, P-H-T-H-A-L, is it E-I-N? We'll see in a minute. I always forget. But phenolphthalein is, its acidic form is colorless and its basic form is pink. Now, we're used to looking at equations like this and finding the Ka value for the acid and making an ice table and figuring out what will be the pH. In other words, we're used to the acid and base driving the pH. Well, if you have just a teeny tiny amount of this conjugate acid-base pair in the presence of other acids and bases which are in a much higher concentration, then this equation will not be driving the pH, it will be responding to the pH which is set by those other more concentrated acids and bases. In other words, what you would do with your ice table is set the H3O plus concentration based on your other acids and bases present in solution, and then calculate your amounts of HA and A minus off of that. We don't need to actually do any of those calculations. We can just talk about this sort of qualitatively in terms of Le Chatelier's principle. If I have this system in the presence of a highly concentrated acid, then that means there will be a lot of H3O plus, and that means that this will be driven far to the left, and so it will be colorless under acidic conditions. And if I have phenolphthalein in a solution which is basic, which has a very low concentration of H3O plus, then that, via Le Chatelier's principle, will drive this equation toward the right, toward this basic form. And it will turn pink. And so where does that transition take place in particular? You'll get equal amounts of HA and A minus when the pH is equal to the pKa. And we can get that from the Henderson-Hasselbalch equation. And so the transition from colorless to pink is going to happen when the pH is equal to the pKa for the acidic form of phenolphthalein. And so over that buffer range of the pKa plus or minus 1 is where we will see this go from 90% colorless to 90% pink. And so there's a relatively narrow pH range where this color transition will occur. So let's look at some figures from the textbook. Here we have, this probably again is phenolphthalein. They're showing that that color change occurs from colorless to pink. And then phenolphthalein has this interesting property where it actually will go colorless again at extremely high pHs. But if you are titrating a strong acid with a strong base, you can see that because that pH climbs so rapidly around the equivalence point, you will have a visible color change just right maybe 1 or even a half a drop beyond that equivalence point. So you'll observe the color change, you'll stop the titration and measure your volume. And technically you will overcount the volume a little bit. You'll have missed the equivalence point by a little bit, but it'll be like less than half a drop. Missing the equivalence point by a little bit is kind of inevitable anyway. Now if you are going for a strong acid titrated by a base titrated by an acid, then maybe you'll want a color indicator who undergoes a color change at lower pHs. Methyl orange, for example, would be a useful indicator for titrating extremely weak bases with strong acid. A very weak base is going to have pH at equivalence that's well below 7, and so you might need something like methyl orange or bromocresol green. For moderately weak bases, bromothymol blue is a good choice. For moderately weak acids and strong acids, phenolphthalein is useful. And then alizarin yellow is useful for extremely weak acids. If you're titrating a very weak acid with a strong base and you need to catch that equivalence point at a much higher pH range, like, I'll just go back a few. Sorry, we're nearly there. Like, oops, too far. Like, for example, this one, where the Ka is very small, 10 to the negative 8, and its equivalence point is higher than 10, well, then you might want to use alizarin yellow R as your color indicator. Now, there is an interactive in your textbook that is fairly robust, and I think it's kind of fun and interesting. You can see, for example, here they show the color that your indicator will be under different pH ranges and exactly where the transition occurs, and it will give you kind of more of a sense of how you want to choose an indicator that is appropriate to whatever you have to be titrating. If you're titrating a weak base, then you figure its equivalence point will be somewhere lower than pH of 7, and so maybe bromocresol green would be a good indicator. And you can kind of investigate how, as you add more or less titrant, the pH will change, and your concentrations of H3O plus and OH minus and the conjugate acid base pair that you're titrating, how all those concentrations change. And anyway, I think that it's a pretty nifty interactive that's there in your textbook. Okay, and again, these ideas are explored in today's quizzes, so I'm gonna go record those right now, and I think they're gonna be really crucial for you to understand this stuff.